Welcome back to the workshop. So in the last episode you saw me make this big plate up here that runs on the linear rails, and then we also made this bracket here that holds this kind of bellows cover on, and actually I think this is going to be about the right size, so I need to offer it up down here or lower it into that gap there, drill the holes through and make that secure, and then I think really the next step we should rebuild the table, and then we can start moving on with some of the upper pieces. Let's get going. I guess before we get into it, it's worth just giving you a quick overview for some of the new subscribers. And this, let's be honest, this series has been running a long time, I think maybe 2 years at least. So there's very little left of the original drill press, but the whole idea was to have a variable speed. It was also to have a rise and fall mechanism on a knee down here, so we've got a custom knee. That means you don't lose position. We've also got an XY table that goes on here, so you can dial it in. We've got digital readouts on there. It goes up to that display there. We also strengthen and stiffen the frame with these side members, so the whole thing's pretty rigid now, and it's also then bolted to the wall by a couple of these little bracing pieces here. Also, to help control the machine, we've got this custom box made on the front here with all the controls, and then over there we've got an electrical cabinet that's got the inverter and the electronics and safety systems such as the overload temperature on the motor. And speaking of the motor, so the original one, it had the motor right at the back there, so this head unit was quite a lot deeper. It ran about another 150mm overhang, and it had a kind of bracket, and the motor hung underneath, traditional style. I was able to cut that off, move the whole drill rearward, and then I've got this 3-phase motor at the top here, made of these custom support brackets. Obviously got to make a belt cover here to make it a bit safe. And then because it's inverter driven, we're able just to run it, well, I've got an option to run it off sort of 2 speeds there. At the moment you can see I've got it on the higher ratio, but if we need it we can drop it down one, and then we can just adjust the motor in there for the belt tension. So in here we've got the power supply, the 3-phase supply, and also there's a temperature sensor in here, so if it gets too hot we'll feed that back and cut off. And yeah, I think that's about it. So let's get started with the table and put it back together. Okay, quick update then. So obviously we've now got the table mounted. You probably saw me replace that horrible gib with a nice brass one that I ordered. I made you the long one as well, but that's actually not too bad condition, so just got the short one done for now. Got that dialed in quite nice, so it's just got a nice firm feel to it. We've just got the X-axis dialed in. It's a little on the stiff side, but I think it will bed in. Now the thing is about this one, that once we've got the DRO mounted, it's a little bit difficult to get access to these bits, so I guess on the tighter side is probably a better option. So we've got that nicely sorted out there, and then I think we just need to mount the DRO and then we can get the cable run sorted out. Okay, I've just got the Y-axis cover on, and then I've clipped the cable up out of the way, so hopefully that won't get caught. Yeah, I think pretty pleased with that. That should work all right. So next we need to put the DRO on. Now before we do that, I need to put the lock system back in, because once the DRO is on you can't get to that. So we'll bring you in close and we'll give you a look at the, well, my attempt at a solution anyway. Okay, so this is a close-up of the lock system for the Y-axis. So the problem I've got is when you put the DRO on, it covers almost half of that hole there, and that's the original lock hole that pushes onto the gib. So I've drilled an additional hole down here. I've got these two, I think these are like little M6 clamp kits for clamping things down onto a milling bed or something like that. And then I've machined this in an earlier video, you might have seen that. So it's got it half cut away and it's just straight on there. That pushes onto the gib, so then that goes into that top hole. So that's originally where the bolt would be like that to do the locking. So you'd have, if you had space, you'd just put something like that in or whatever. But I don't have the space, so we've got that at the bottom. And then this is a bit I made in an earlier video, and you can see, so it's all been machined out of a block, and then I cold blued it to give it a little bit of protection. So you'll see a couple of things. So it's got a kind of foot at the bottom that pivots about, and then there's a little recess at the top, and that's the bit that just sits against there. So it goes in a bit like that. Okay, somewhere, not quite. Okay, somewhere about there. So the way it works is, as you turn this, pushes onto that piece, pushes on that pin. So that's lock, that's unlock. You may be able to see it moving ever so slightly. Lock and unlock. Simple as that. Now it does hold the axis a little bit, but you can power past it if you really want to turn it. So it's something. It's not perfect. Let me just show you that. So we'll lock it. And although it's pretty stiff, if I wanted to, I could make the axis move, but it does take some effort to do it. So anyway, after a lot of thinking about different ways to do it, that's what I came up with. It's not super neat. I did originally have it without these two pieces, but this forever moved around, didn't stay in line, so at least we've got that. There's not a lot of room to play with because you're next to this, you haven't got much real estate below it. Above it, as you'll see in a minute, the DRO comes up against there. So yeah, it's something, it will lock it off. I think it'll be alright for when you're drilling a hole. You're not milling anything, you're not going sideways, so there's nothing hopefully really kind of pushing it out of the way. So see how we get on. If you've had a similar experience and you've overcome it, do let me know if you've got a nice idea. Yeah, leave a comment below. Okay, well, I've been having some problems with the battery in this iPhone, so while it was deciding whether it was going to charge or not, pressed on. So I've made the spacers, got this cover plate mounted, got the cable guide mounted there, and the same for the other axis over there. And as you can see, we've got the vise mounted, so we're just tramming that in. Let me just switch on the DROs and I can show you where we're at. So here's a close-up of the cover plate, and you can see I made a little spacer in there. So this clamps to that, and then I made that spacer just the right dimension so it holds it off, so that it pushes neatly into that edge. You get a nice flush finish there. It's also holding DRO in place. And then on this side you can see you've got the Y-axis reed head there, the cable all clipped up out of the way onto this cover, and then there's the X-axis reed head here, and then again that's clipped on this cover. So this cover moves with this axis, so that's why it's all tied together. There's enough slack in the back to make that happen, and then it just hangs out the back, so it's well clear of the wall when it goes rearward. So that's the cable runs at this side, and then from there they come round, clip together, so there's enough slack for them to move around there, and then there. tied up round here and into the back of the unit. So we should have our DRO working on all axes. Let's switch it on and show you that in action. So as you can see, I've got the DTI set up here, and I'm just running it across the back jaw there so it can dial this vice in. I'm not sure if this is the final vice I'll use for this. It's pretty low profile, so that's pretty good, but I'll see how we get on. I'm just really trying it out and seeing where it works, where it doesn't. So for example, these are quite long, so if I've got a wide piece in there, it's going to hit that, so maybe I need to make some shorter ones, you know, that kind of thing. And the other thing is where this DTI magnetically picks up on the cast iron, it's a bit of a rough surface, so it doesn't fit very well, and it's not very strong magnetic surface on there, so maybe we'll make something dedicated. But you know, these are things I need to try out. But the one thing we can do is move the axes and show you where we've got to. So as we move across there, it bumps around a bit. This is not a precision ground surface by any means. But pretty much got that dialed into a win of about 0.01, which I think for what we need will be plenty good enough. The other thing you can see is we've now got our DRO working, so as we move that across, got our x-axis readout, and also y-axis. Just make sure I don't break the tip. Let's move it away. There we go. So we can bring that back into a 0 and then sweep it along. Okay, I won't show it again, but when we move it up and down, we have the Z-axis moving as well. So, good progress. So why are we doing this, you may ask? Well, let me show you. So in the last video, you may remember, we made this piece. This is the piece that goes right at the top of the drill press and it moves up and down with the quill, because there'll be a little block that's connected in here. Now we did everything, we CNC machined it out, did all the pockets and tapped the holes. The only thing we didn't do is put the 2 holes in the top. The reason for that was I've kind of got the CNC machine set up for big plate work, and I've got another piece to cut out. In fact, it's the piece that goes in here, and I would have to break that setup down and then put the vice in, pick up off these edges, drill these holes to get it really accurate. And I thought, well, this is why I built this drilling machine. The idea is that you should be able to just pick up off a couple of edges and drill a hole in a reasonably precision location. So I've taken the piece off the machine. We've got to put 2 M8s in here, exactly where it's mentioned on the drawing. So we'll put this in the vise, and then we'll edge find it. We'll centre those, and then just drill and tap them. Let's see how we get on. Oh, is this first chips? No, this is not officially first chips. We're just going to use it to mark out these holes, drill and tap them, and get this piece done. We'll do proper first chips when we finish the whole machine. Can we do some milling as well? Leave it. I'm sure you've seen these things before, but just in case, let me just go over how it works. This is an edge finder, so this part here goes into the quill, or into the chuck, and then this part here, it moves. So it's there's a little spring between the two, and then there are some greased surfaces. So they both rotate, and then this one you set offset like that, and then you rub this one against the edge you want to find, and what happens is, because it forces them to be concentric, and they eventually run true like that, when you're right on that edge, and then as soon as you push it a little bit further, move on the axes a little bit further, it pushes this, it grips, and then it will kick out like that, and then you know you're on the edge, well, plus the radius of this probing area. Right, let's get on with it. Right, so because of that chamfer there, we're going to have to pick up off the 4mm diameter one, not the 10, that's fine. So start the spindle. And bring the axis over. Start to bring it in line. Somewhere there. There, it's just kicked out there. Okay. So on the DRO we'll put X minus 2. Okay, we'll pick up off this edge now. There, it's just kicked out. So we can put -2 on the Y. Okay, we should be set. So on the drawing, this is at 80 and 10. So let's get ourselves aligned according to the DRO. Oh, I've shut it. Okay, 80 in X and 10 in Y. Okay, that should be centered. Looks pretty good. Alright, let's get drilling it. So I need to lock this axis, but this is the best I've got at the moment, so we'll use that, but I want to make something sort of tubular like that with some knurled ends. I've only got this height, this clearance, so it's going to be quite small. I can't have it sticking out too far because it will get a little bit too close to the handle that's just down here, but that's to come. I knew that was coming, but for now I'll just lock it off best we can. And then these two side ones down here. Right, hopefully the table won't move now. I've got a 3mm spotting drill in there, so we'll just take that centre out. While I was drilling that, you probably heard that kind of knocking noise. So it's free play between the spindle that's in here, or the spline on the spindle side, and then the other spline inside the pulley. Yeah, it's just worn out over all these years of use because it has to slide as well as transmit that power. So it's also not helped by the fact the pulleys are eccentric, they're not turned true, they're not running true. So I've decided as a future project I will make some pulleys, and that will help a lot. I'll just turn those, because now I know I just need the 2 speeds, just kind of that low and medium speed pulleys. I don't need the full 5 because I've got the inverter to do that. That should help an awful lot, so it won't fluctuate as much, and then we'll see what the noise is like and then take it from there. I might have to do something more drastic, but for now it's working, so let's drill this out. Okay, so next up we're just going to try some tapping. So this is our M8 tap, and we're just going to use the jog function that I built in. So this drives a special function on the inverter over there, and it just runs as long as you hold this, and it runs at a speed that I've set in there. So if I push this one, it should tap clockwise. That's looking a bit fast actually from the first tap, but that's what that'll do. And then you want to come out again, go the other way. So we'll put some WD-40 on that, get it set up, and then we'll jog it down. What I think I might do is just get the tap thread established, and then just hand tap the rest. You know, I'm just feeling my way through and just seeing how I get on with this. But at least if I establish it square, that'll be a good start. And then maybe I'll get braver on the other one and do the whole lot. Let's have a look. But I haven't got any clutch in here, so you know, I don't want it to bottom out or break this. I've got quite a lot of hours into this job, so let's get that tap started at least. Oop. Looks like it's starting to lift the part. I think I need to slow that down because I was struggling to keep the feed rate up on the handle up with that. Yeah, you know, first steps. Yeah. That could have gone a lot worse. Alright, I think we started that. Let's do that one and then I'll hand finish these off. Okay, so we're now at 180. We're over the other hole, so let's just repeat. So I'll bring that out, we should be able to hand tap it. Okay, start with this one. Okay, that was our first kind of unofficial use of the drill press just to get this little job done. So what did we learn from that? Well, this little vise here I've had for ages. By the way, in the catalogue that I ordered it from, it was a black or charcoal grey, and they sent me this nice lilac one. I keep meaning to strip it down and spray it, probably the same, you know, the same grey as this. I've got plenty of that left, but you know, I wanted to see if it was going to be up to the job really, and actually I think it's okay. If I remade a vise, which was one of my original ideas, be pretty close to these dimensions. I think it's about as short as you can get away with, but still be pretty strong enough and stiff enough to do the job. These bolts are too long, so obviously I need to make some custom ones. I don't really want to cut these down because I might need some longer ones, so it's just some T-bolts. That's not a big job. If I can get them so that the bolt is flush there, lower than the vise jaw at the bottom there, then that will be good. What else do we know? Yeah, obviously it generates a lot of chips, so I need to get the cover sorted out. This is about the lowest position you can go. As you can see, you're almost at the bottom. Now when I was designing this, I wasn't quite sure because I had to measure all this. There was no CAD model available. I had to measure it all, and I didn't want to make these parts too big and not fit, so I erred on the side of caution and made sure I didn't hit those bolts. Reality, I could have scooped that plate round, ordered some longer rails and got maybe another 20mm on the Z height there. And the reason for that is, well, let's just have a look around the side. You got the blocks pretty much close as they can be. I was allowing for a grease fitting in there should I need one. I think I'll end up putting them in maybe top and bottom in the end, but they're about as close as they can go. And then you've got the Z stack up for the actual table itself, which gets you to here, and then you've got the vise, and that, so you kind of, that's your top there, and then you're limited by this throat or this depth here. It's getting a little bit tight there. I just about managed to get the drill in, but with some really long ones I might struggle if you've got a very tall part like this. But that's kind of getting towards the limit. I guess I could look for a much more compact chuck. That would buy me another 20mm or so. In terms of wide travel, yeah, we are hitting, I was just trying it out, we do hit this first. So I'll definitely swap that out and make a much shallower one. That will buy me about another 10-15mm in Y, and you know, that's always critical on a machine or drill or any milling machine. That wide dimension is always critical, so we learned that. Yeah, I think the jog speed was a little bit too fast, so we can tune that down for the tapping. And oh yeah, I really don't like that. It's completely awkward to use and nasty, so we'll do something about that. That was always the plan anyway, but you know, that's kind of what we got for now. And I think that was it. I mean, it did the job. we're able to mark it out, drill, tap. Pretty happy in principle, but there's a few little things to do to improve it. Right, onwards. Okay, so next up we're going to make the quill support plate. So this is the bit that holds the quill in place, and then it bolts on via these two holes here onto the back plate that we made earlier. And so there's quite a few features to machine on this, so it looks a little bit complicated. We've got our pinch bolt arrangement here that clamps together around the quill. You can see it a little bit easier on the ISO views down here. Then we've got a big pocket here, that'll be for a light that goes in to illuminate the work. And then this slot over here, this is for, there's a big rod that comes out of here, and that's for the depth stop, so we can both adjust the depth stop and also we can go to a certain depth and hold it there. So it's kind of a lock feature on the depth. And then there's a few other tapped holes and things for various bits of feature. I think this one here is to hold the DRO on, which we'll come to a bit later. And then in the side there you can see there's been spots drilled, and then it will be counterbored to have the pinch bolt in there to hold this piece onto the quill. So I think that's about everything. Okay, before we machine that part, I just drew something up in Fusion 360, which is basically a relief pocket that the blank is going to fit into, and I just made sure we've got some of those corners relieved as well, so it will definitely sit in there. That does a couple of things. One, it aligns it nicely, that's not critical, but the main thing is it will stop it moving around and it gives it a little bit more location. So we'll just machine that out now, and then we can set the part up. Okay, so managed to successfully bore that out. A couple of things to note there. It was, I think the cutter's getting pretty blunt, so it was struggling a little bit in places. So I've just got some new ones. I'll swap them out before we do the next cut. Second thing is, yeah, I really could do with mist coolant, some kind of air compressor, some kind of fog buster type system linked up here. So I really do need to do that. And you know, one of these days when I'm feeling a little bit more flush and got a bit more spare cash, I really should get around to making and buying an aluminium fixture plate. This is just not rigid enough. You can feel it vibrating, and that's obviously affecting how well it cuts. If this is really rigid and the machine's rigid and you've got a sharp cutter, it should be no problem. You should be able to really fly through this. Okay, so this is where we're at. So the next thing I'm going to do, I turn this on the lathe. This is just a bit of scrap, so I've just turned that ID there so it matches that there. That'll be a kind of hold down, and then just drill this out to 8mm. Now this took more time than it should have, basically because in the lathe you're kind of between sizes, so it's between, there's a magical diameter where you can't quite get it with the outer jaws or the inside jaws, or the jaws the other way around. So had to make up a little mandrel and then hold that, which meant I couldn't quite get all the way to the end there because the mandrel's kind of holding it. But you know, we got there, we got a functional part, so that will just go in there just to give us another hold down. I've just got it, yeah, pulled the plastic out of the way so we get a nice solid finish there. So I'll just drill that, put another wood nut in there, and then put the M8 bolt in there, and that'll hold that down. That'll help when we cut the final profile. Right, let's drill that and then we'll carry on. Okay, so these need to be 10mm, it's a 20mm part, so they need to be 10mm on the base. Okay, and on the drawing, do it that way around. This one needs to be 12 from that edge, and this one's 6 from this edge. Okay, so we'll do the 12 first. Just about get in. Well, I wasn't going to film this bit, but I just drilled it out with about a 2.5mm drill just to pilot it out, because this is going to be tapped for M5. And I was just about to finish drilling to pull it out, and it decided to break. So it's broken the drill off probably about 6mm into the part. So I'll probably resign myself to the fact I'm going to have to probably put an M8 here. That's okay, it's just a fixing for a bracket. I can go up a size. And then I've just drilled 2 little pilot holes either side, and I'm just trying to drill either side of the bit, and then maybe I can just lever it out. I didn't feel like it was massively tight, it just suddenly snapped. So it might not have bound up in there. So maybe we'll get a bit of WD-40 in it actually and see if we can prise it out. Oh, ran out. It's not going well, is it? Last little bit. Maybe. I don't know if that was it, or I've just broken a piece off. Let's just see. I'll soon tell. Nope, that's hitting a drill. I've just been drilling away, and I think I've got it out. Let's see if I can drill down this middle one. Ah. Snap that off. Luckily that went flying. I think today I've got a blunt 6mm end mill. I've broken 2 or 3 3mm end mills, and I've broken 2 twist drills. It's not going well, is it? At least the part is getting there. Right, let's see if we can open that up. That's got it. There was a tiny bit of drill left down at the bottom, so just used an end mill. Started the hole out with a 6mm twist drill and then used the end mill just to... This is an old one. That sorted it. We're down to clean metal. Right, let's tap this. I'll just change that into CAD to M8 and no one will ever know. Okay, so let me talk you through the setup here. So this is the Quill back plate that we were machining earlier and drilled and tapped those holes. I just left it in the vise. Actually, luckily I did, because I was able just to bring this up and use the bed to make it square and clamp it here. So it's got a nice support. So that's nice and rigid now. And then I've just put a 3mm twist drill in here, and I picked up off the centre and now zeroed it on the DRO, now ready to go. So because a twist drill is going to probably move out of alignment, it's drilling through probably about that much aluminium, I'm just going to try and end mill through here first, because they made a carbide and they're pretty stiff. I just swapped this out for a 6mm twist drill. I had to move the work out of the way to use this space to actually get it in there, because it's a little bit tight. This is about as tall a piece as I can drill. Right, so we're in, and there we go. Oh, it's drilling a lot better. Right, I've taken it out of the drill press and I'm basically holding it on about the last 2 or 3 millimeters of the shank. It should just put, as you can see, it's just starting to come through, so hopefully it doesn't grab and then pull it out the chuck and have the drill stuck in there. That will not be good, so take it nice and easy. Alright, just the last little bit to go. So I thought while I was here, I don't want to tap all that M8, so I've counterbored it to about here with a 10mm drill, and then this bit will be tapped and this bit will be relieved. So let's just tidy that up a bit. Okay, well basically had to work my way up in sizes, up from the 6, 6.5, 7, 7.5, and of course you're drilling on a bit of an angle, so I was just keeping the pressure down, checking every now and again just to make sure I was nice and straight. So we're keeping that straight, and now this is not ideal. I can't fit in the milling machine because it's too tall and doesn't fit in the drill press. It's just there's not enough space really. It's just too tall again. So I'm just trying to keep even pressure to try and keep this as centralized as possible. It's not bad. It's about staying on track. But it's not the best way to do it. Once it gets established, it'll be okay. Okay, I think that'll do it. Right, so all we've got to do now is tap that M8 on this side. Okay, I've cleaned it up a bit, opened the bore out a little bit, just give me some clearance, and then you drop the Allen key. Now it's starting to squeeze it up. Right, now I have done a trial fit of this on the Quill, and the Quill, the outer part is not completely round, it's close, so it just about goes on, but it's a bit oval. So what I've worked out I'm going to do is just put the thread in the other side and then just put a washer in there and use that as a kind of jacking screw to just open this out, drop it on the Quill, and then it should give a nice tight fit. But you know, you do what you can. Right, so next up we need to make 2 of these little brackets. They're made out of 10mm plate. Okay, so basically got a pocket in the centre here. Now because there's nowhere to hold it really, I've got a couple of tabs in cam, which once we've cut it out we'll just file those flush. Then we've got 2 M8s, which is a little bit tight on a 10mm part, but I think it'll be fine. And then we've got a 5mm slot here. It's slotted because I need to allow for any discrepancies between the Quill and the back of the machine, because I've measured the whole thing with a tape measure and ruler as best I can, but that's just to take up any of those discrepancies. So we've got the part on the machine, so let's go and cut it out. Okay, I've just offered it up, and I haven't filmed all this because it's a bit fiddly just to get everything in position, but essentially I've got the quill jammed down here a little bit to give me a little bit of space, so that's just holding that down, and then I've put the screw in the wrong end, so it's pushing against this washer that's opening this out because it's a little bit tight on here. The idea is that I'll open this collar out, get it onto there, get it nicely lined up, and then as I back that out it should squeeze. Actually that might be enough to hold it, but you know, I'll put the screw in just to give a nice clamping area. And then what you got to be careful of is then you've got kind of competing geometries here. So you've got the center line of the quill, and then it sort of goes all the way around to the rails here, and I'm basically joining those together, and this will obviously want to move in pretty much the plane it's at, so I have to back out these screws a little bit, that's why they're slotted, and back out these so I can adjust this so it's nicely on here. So that's the first reference, and then this plate is nicely on the bearings, that's the other reference, and then nip it all back up, sort of move it up and down and make sure it doesn't feel like it's trying to bind, you know, and it feels like it's all square and happy basically. So I'll have a bit of a fiddle around with this, and I'm just, so you can see, I'm just easing it up onto there. It won't go all the way to the top, it stops about 5mm short, but it's plenty enough to grab onto it. Oh, that's coming out. Has come out. Oh, the quill goes. yeah, I'll set this up, get it all aligned, get it adjusted, and then I'll bring you back and just show you it kind of installed. It's a bit fiddly. Well, this is kind of where I got to with it. It's not absolutely perfectly aligned. So the problem is that this plate here, I can move it in and out because it's slotted here and it's slotted at the back. So I can get that in alignment. And I can also rotate it this way because I can loosen these off and I can kind of skew it a little bit and set it at whatever angle this wants to be. The only one I can't really adjust is this way, because I've got this fixed kind of 90 degrees here, and then basically it's dictated by the face of these bearing blocks here, and if this doesn't run up and down exactly in line with the spindle, you know, if they're kind of like that, then it's sort of, it's not super, you see it sort of stutters a little bit. So you go, actually it's not too bad, but it's, yeah, so it doesn't quite want to go all the way back. It's pretty close. It's just binding ever so slightly. So I have put some grease on here just to help it, but it's doesn't feel like it's quite there. So what I decided to do, I've buttoned it all back up again. The video's getting quite long now, so we'll finish it out there. I always knew this was going to be the last bit to do, and just there's no real way in CAD to sort of predict where you're going to end up, how exactly this plane is going to line to this one. So I thought when I got to this point, I'll see what I've got. What I think it needs is a tiny shim behind the base here, just to pull this out and just kind of change the angle like that, and then it will line up a lot better with this, and then it should be quite smooth. If that doesn't work, then the other idea I had and what I was going to do was to put maybe 1 or 2, 3, 4 jacking screws, some arrangement, so basically I can jack this away from the bearing face, or this bearing block here, and then tighten it up and basically adjust this angle, because that's always the one I couldn't really easily design in. Anyway, that's kind of what we got, and I think you can see how it's all sort of come together now. While we're over here, we'll just talk a little bit about the next step. So we're going to put a big bar in here, and that will run inside a kind of guide bush, and that bush will sit inside a housing that runs off a huge bracket that comes out of here basically, and that will form, well, there'll be 3 functions there. One is once I drop the quill to a certain location, if I'm trying to mark the top of a piece of work or want it to just stay at that location, I'll be able to lock off a little thumb screw and hold this plate at just the height I need. The other thing I'll be able to do is once it goes down to a certain depth, there'll be a kind of stop collar, so it'll always drill a depth, say 10, 15 mil, whatever you're doing, counter boring, whatever. So you can do that, that's the second function. And then the third one is this bracket on the side, which was going to be M5, but turned out to be M8, but no loss there. There'll be a little bracket that comes off here, and there'll be a digital readout, a bit like, I haven't got it here, but essentially a kind of, it's a version of this. It'll sit on the side here, and that will give me a Z position for the quill. That's in addition to the DRO. So the DRO will tell me where the knee is in height, and then the quill readout will be on there. So it's sort of those 3 functions in one. So that is yet to come. Now the other thing worth noting is, so you can see, now I've got this plate on, that the original light, which is up there, which is shining down, a lot of it's blocked out and it's not really illuminating the area. I kind of thought that was going to happen, which is why I opened up this hole here. We just about see that hole there, and the idea was to see how much light came down, and then I'm pretty sure the answer was going to be not very much. So I've tapped 2 holes, and basically I made that the right size for one of these. I think this is off a car sort of side light thing, 12 volts off eBay, and then that goes in there, and it will feed through there, and I'll get nice bright light from here shining down, so that should be pretty good. And then this will just wire back into the control box. So if you enjoyed it, let me know, give me a thumbs up, and see you next time.